We are living through something genuinely historic right now, and not in a clickbait way, in actual look back in 50 years kind of way. Humanoid robots are no longer a science fiction promise. They're being built, shipped, deployed, and in some cases, sweating. Literally sweating. Today, I'm walking you through 5 robots that, in my opinion, represent the cutting edge of what it means to be human-like in 2025 and 2026. And not just in looks, but in movement, in sensation, in capability, and in the very real possibility that some of them might be coming for our jobs. So let's get into it. Now, I want to start with the one that genuinely made my jaw drop when I first saw the footage, and I don't say that lightly. Protoclone, built by a Polish startup called Clone Robotics, is what happens when engineers stop asking, how do we build a robot, and start asking, how do we copy a human? I mean that literally. This thing is constructed around 206 bones, articulated joints, ligaments, connective tissue, and over 1,000 synthetic muscles called myofibers, all attached to the skeleton at precise anatomical points, the exact same way real muscle tissues attach to bone in your body. It has 500 sensors. It moves across more than 200 degrees of freedom, and nothing else in this space comes anywhere close to that. Now, when the Protoclone clip first dropped in early 2025, it pulled millions of views within hours. The reactions ranged from "this is incredible" to "I'm not sleeping tonight." And you can see the robot hanging in a harness, translucent skin stretched over synthetic muscles that are visibly twitching underneath. It is one of those things you cannot unsee. Dar Sleeper, head of growth and OpenAI-backed startup iX Technologies, said that the design couldn't get any cooler or any creepier. He was right on both counts. What sets Protoclone apart is that it runs on pneumatic systems right now, basically pressurized air, with plans to switch to hydraulics for better precision and strength in later versions. It also has bio-inspired cooling system that is essentially mechanical sweating. Let me just reiterate that. The robot sweats to stop its muscles from overheating. Clone co-founder Lukasz Kozlik has been very open about the mission. He wants to build machines that are indistinguishable from living people, mimicking human anatomy from the deepest tissue layers outward. They've been taking direct shots at Tesla, claiming their muscle-based architecture gives them structural advantages that rigid actuator robots simply cannot replace. The real caveat, though, is that the Protoclone hasn't walked on its own yet. It still needs a harness, but the company says untethered locomotion is coming, and that the main bottleneck right now is software, specifically control and simulation systems that need to understand biology more than machinery. Now, that's actually a fascinating reframe because the hardware might be good enough, but the brain is what needs to catch up. Personally, I think Clone Robotics is building the most philosophically interesting robot on this list. Everyone else is asking how to make a capable robot. These guys are asking how to make a human. Those are very different questions, and the result looks completely different too. Now, if Protoclone was the most organic, Atlas is definitely the most accomplished. Boston Dynamics has been at this for over 30 years, and their newest all-electric Atlas, unveiled as a commercial product at CES 2026 in Las Vegas, is the clearest proof that they're operating in a completely different league when it comes down to physical performance. Atlas stands 5'9", weighs 200 pounds, and runs on all-electric actuators capable of 360-degree rotation at key joints. It integrates LiDAR, stereo cameras, depth sensors, and RGB cameras for real-time environmental awareness. The AI models run on NVIDIA processors on board, but here is the part that actually matters. It's already doing real work. Not a polished lab demo, actual field testing at Hyundai's manufacturing plant in Georgia, sorting roof rack parts and handling sequencing tasks alongside over 1,000 industrial robots and 1,500 human workers. In August 2025, Boston Dynamics and Toyota Research Institute jointly announced that they had demonstrated a large behavior model powering Atlas. That means Atlas can now carry on long continuous sequences of complex tasks that combine object manipulation with locomotion, and new capabilities can be added without writing a single new line of code. This is a massive deal. The robot learns the way modern AI learns, and not the way an industrial arm from the 90s got hand-programmed. They reveal the commercial version at Hyundai's CES 2026 keynote, and here is the number that tells you everything you need to know. Every Atlas deployment for 2026 is already fully committed. Hyundai's plans got the first fleets. Google DeepMind is next, planning to use Atlas as a platform for training foundation models, and pricing sits somewhere between $150,000 and $420,000 per unit. This is definitely not a consumer robot. It is an enterprise infrastructure. My take on Atlas is pretty simple. It's the robot that actually works right now, today, and not in a we filmed a highlighted real way, but in a we're shipping to factories and taking real orders way. The track record backs up every claim they make, and when Google DeepMind wants something as its AI training platform, that is about as strong of an endorsement as anything in the industry is going to get. But if Atlas sounds interesting and unbelievable to you, hold your horses, because next up is Eva.i, and this is by far the most expressive humanoid. This is where we shift away from industrial strength and towards something I'd argue matters just as much in the long run. Meet Eva.i, built by IO Technology under the Robnova.i brand. Eva.i, or Eva.i, debuted publicly in December 2025, and it takes a completely different approach to human likeness. Rather than replacing the human body in motion, it focuses on something that might actually matter more in everyday human-robot interaction: the face, and everything that happens on it. Eva.i runs what IO calls a 3-layer sensing system, combined with bionic electronic skin developed together with researchers from the Chinese Academy of Sciences in Shenzhen. The robot reads emotional cues through text, voice tone, and body language simultaneously, and then responds using micro-expressions. Those small, subtle facial movements that carry most of the nuance in any real conversation. The aesthetic design was handled by a former Marvel Studios prop and collectible designer with 18 years of experience. That's not a random hire. It's exactly why this thing looks so compelling rather than unsettling. The AI behind the emotional system was led by a technical director with a PhD in computer science from the University of Washington. The goal was never just a robot that could smile on command. It was something that could function as a genuine companion, something that picks up on psychological context and responds in ways that feel real rather than scripted. The company framed it openly as a tool against digital loneliness and launched a Kickstarter campaign to put it directly into people's hands. Now, what gets me about Eva.i is that it takes on the part of human likeness that every single industrial robot on this list ignores completely. Atlas can sort factory parts, Optimus can fold laundry, but can either of them hold a real conversation and make you feel like something actually heard you? Eva.i is built for exactly that, and as robots start moving into homes, hospitals, and care facilities, that kind of emotional range is going to matter a lot, especially in elder care, where loneliness causes real, measurable harm. Now, this one is a little different from the others because it's not a standalone robot, it's a technology, but it belongs on this list because it solves a fundamental limitation that almost every humanoid on the market shares. They can't feel anything. JQ Industries built a fabric-based electronic skin using piezoresistive flexible tactile sensors, which are basically woven fiber sensors that wrap around a robot's body the way clothing wraps around ours. When installed on a humanoid like the Unitree G1, the entire body surface becomes touch sensitive. A light touch converts into electrical signals, measuring pressure, deformation, and slip in real time, and all processed by AI for closed-loop control. The whole system integrates with NVIDIA Isaac Sim. The specs are genuinely impressive. The glove compartment delivers multi-point tactile feedback across the full palm, handles joint folds down to 0 degrees, and detects forces as low as 0.01 newtons with a sensitivity ceiling of 3,500 kilopascals. That range covers everything from the faintest fingertip contact to a firm, deliberate grip. In practice, this unlocks a lot. A robot with an E-skin installed can halt mid-movement the instant it makes an unexpected contact, catching collisions before they cause damage. More interestingly, it can tell the difference between a hug, a tap on the shoulder, and a shove, and it can respond to each one differently. The company specifically highlighted elder care and medical rehabilitation as primary use cases. Think about a robot helping someone stand up without bruising fragile skin, or guiding someone through physical therapy with actual calibrated tactile feedback. By mid-2025, JQ Industries was in active talks with more than 10 humanoid robotics companies for upper body and limb skin supply, and volume shipments were already going out. I am genuinely excited about this one because it fills the last major gap in robotic sensory experience. Touch is a huge part of how humans interact with each other and with the world around them. E-skin is the first practical, scalable attempt to give robots access to that. And then there's Optimus, the one everybody's heard of, the one Elon Musk calls potentially the biggest product of all time. The scale of ambition here is genuinely hard to wrap your head around. Tesla Gen 2 is already running at 2 factories, Fremont in California and Giga Texas in Austin, handling battery cell sorting, parts transport, kitting, and quality inspections. The Gen 3 hands were recently revealed, featuring a serious dexterity upgrade with 22 degrees of freedom and all 25 actuators sitting inside the forearm for clean, manufacturable design. Tesla is converting the Fremont Model S and X production lines into a dedicated Optimus hub targeting 1 million units per year. They also broke ground at Giga Texas on a facility aimed at 10 million robots annually by 2027, nonetheless. Now, to be fair, the pace has been slower than the headlines made it sound. The Q4 2025 earnings call in January 2026 told us that Musk said that the deployment units are not doing useful work yet. They're there to learn and collect data. The 5,000 unit target for 2025 was missed. Gen 3 is running behind. And these aren't minor footnotes, they're real gaps between promise and delivery, but here's why I'd still put my money on Optimus being the one that actually displaces human workers at scale: the data flywheel. Every robot Tesla puts on a factory floor generates training data that no competitor can match in volume. The June 2025 decision to bring in Ashok Eluswamy, the engineer who ran Tesla Autopilot, to lead the Optimus program tells you everything about the strategy. Tesla is treating this like they're treating self-driving, an AI problem first, a hardware problem second. Target consumer pricing is under $20,000. Let me remind you that Boston Dynamics Atlas could cost you $150,000 or more. If Tesla gets Optimus to good enough at roughly 1/7 of the price, the entire calculation changes for any business looking at humanoid labor. That's the bet on the table, and it's one worth watching closely. So there it is. 5 robots, 5 completely different takes on what human-like actually means. Clone Robotics is building the most anatomically faithful machine ever attempted. Boston Dynamics is already shipping something that works in the real world. Eva.i is solving the emotional dimension that every other robot skips over entirely. JQ Industries is giving machines the ability to actually feel. And Tesla Tesla is doing what Tesla does, going after mass scale at a price that could genuinely change the game. None of these is the final answer yet by itself. The humanoid that eventually ends up in your home, your hospital, your warehouse is probably going to pull from all 5 of them. The organic movement of Protoclone, the raw capability of Atlas, the emotional range of Eva.i, the tactile sensitivity of E-Skin, and the manufacturing scale of Optimus are all rolled into one. And we're not there yet, but we're closer than most people realize, and I find that more exciting than anything else right now. These machines aren't here to replace what makes us human, they're here to extend what's possible, and I genuinely can't wait to see what the next 2 years bring.